Hey all you cool cats and kittens, we're back for the last part of these beautiful notes. And what I did when you were gone was I made this angle, our favorite angle here, and then I labeled this as theta. Okay, that's our reference angle. Okay, so if this is our original angle here, then theta is going to be our reference angle, okay? Now we're going to have to think back to some trig, but we're going to do some cool things. So the first thing I want you to do is draw a line from the arrow just straight down to the x-axis. So when we do that, we can see it makes this right triangle here, okay? Now, this right triangle, I'm going to put a point here. And we're going to call this point X, Y. All right, so the distance that we travel on the x-axis is the absolute value of x. Okay, the reason why we say it's the absolute value is because based on this position, it's technically on the negative part of the x-axis, but this is going to be in terms of distance. And this would be the absolute value of y, or you can just think of it as y, but it is going to be the positive values here, okay? So we are going to label this part of the triangle as R. Okay, and the reason why it is called R is because this is going to relate to a circle later, and we will think of this as the radius. And then we can set up a few equations from this triangle. So when I said think back to SOHCAHTOA, remember we had the sine of theta that was the opposite over the hypotenuse. So we can think of this as the sine of theta equals, so this is your theta, the opposite is y, the hypotenuse is r. So we're going to think of it as y over r. Okay, and this is going to be the actual y. Okay, so not the absolute value, but the actual y. And then for cosine, which is the adjacent over the hypotenuse, is going to be x over r. Okay, that's going to be the ratio. And then that means your tangent of theta is going to be opposite over adjacent, which would be y over x. Now, along with this equation, you will see the stipulation. The x can't be 0, because if it was, then that would be undefined. Okay? Now, you can also set up an equation to find r. So this is a right triangle, so we can use the Pythagorean theorem. So we know that the hypotenuse squared equals the sum of the two legs squared, which are x and y. Okay, so x squared plus y squared equals r squared. Or if you wanted to solve this for r, you would just take the square roots of both sides. So this would lead to r equals the square root of x squared plus y squared. And you don't need the plus or minus in this case because we are going to use the positive because it's representing a distance there. Okay, so based on those definitions, we can go on to our next example. So we're given a point that is on the terminal side of theta in the standard position. That's going to be just like the point we had in our picture before. We have to find, oh geez, this is probably my mom. Pause it. All right, well, wasn't that exciting? Like Mr. Rogers' Neighborhood over here. My mom dropped off some groceries for me. God love her. All right, as we were finding the exact value of the 6 trigonometric functions for theta. Okay, so first, when it does say exact, what does that mean? No decimals. Okay, no rounded answers. If you're finding the exact value, then you're going to keep it in radical form. All right, so for point P, you can think of this as your x, and this is your y. Okay, and we're just going to draw a little visual representation. And maybe I'll get fancy and use my straight edge, because why not? Whoopsies. It's hitting the camera. Okay, guess we'll just do this. Alright, so let's think about where the point -6, +9 would be. We can just estimate. So -6 would be on the x-axis, negative, and then up here to 9. Really, as long as it's in the proper quadrant, I'm cool with that. Okay, and then you are going to connect the point to the origin. And then you're going to make a right triangle with the axis. Okay, so point to origin and then point to the x-axis. All right, so now we are going to label this as -6. Okay, because you'd be going to the left 6 and then you'd be going up 9. And then remember, this is our theta value. Okay. This is your R. So to find R, which is your hypotenuse, you're going to use the Pythagorean theorem. So step 1, find R. I'm just going to use PT. All right, so then if we do -6 squared plus 9 squared, that's going to equal R squared. Remember, you can just take the square root of both sides to get R. So this is going to be 36 plus 81, which is going to get you 117. And then you want to look for perfect squares. Right away, the first perfect square that you usually check is 4. And because it's not even, 4 is not going to go in there. So the next one you check is 9. So if I do 117 divided by 9, I'll find it goes in there 13 times. Which means your R value is 3√13. Okay. So we know R is 3√13 now, and that is going to be our hypotenuse. Okay. So now we can find our trig functions. So step 2, find trig functions. And we will start with sine. So the sine of theta we just talked about is going to be y over r. Again, it's the same thing as your O over h. So the opposite 9, which is your y, over your r value, which is 3√13. Okay, and then we are going to have to rationalize. I would simplify first. So 9 divided by 3 is 3, so that goes on top. So it's 3 over √13. And then to rationalize, you're going to multiply the top and the bottom by √13 over √13. So this would be 3√13 over 13. You cannot reduce that now because 3 does not go into 13. Okay, sorry, hope that's good. Okay, now the next one that I would do is the reciprocal function. So the reciprocal of sine is the cosecant. Okay, so then if you did r over y, it would be 3√13 over 9. 3 goes into 9 3 times. So this would be √13 over 3. Okay, and that's how I would always do it, is I would do the function and then the function's reciprocal. And then I am just writing those on the final line. All right, so now we're going to do cosine. So the cosine is going to be x over r. So your x value is -6. Your r value is 3√13. And again, you are going to take that sign. Okay, so it's negative here. You do need to do that. Okay, and 3 goes into 6 2 times, so you'll have -2 on top over root 13, and then you are going to rationalize. Okay, so you have -2 root 13 over 13. And then you're going to do the reciprocal, which is the secant. Okay, so the secant would be r over x. And really, you can see this is the reduced version here. So this is going to reduce to root 13 over -2. And the negative you can put right in front, negative root 13 over 2 as your final answer. All right, and then we got the tangent and the cotangent. All right, and remember this is the reciprocal of your cosine. So now we have the tangent, which is y over x. Oh, sorry, that looks a little blurry. And your y value is 9. Your x value is 6, -6, so we're just going to reduce. Divide by 3, divide by 3, and you will get -3 over 2. Its reciprocal would be -2 over 3. Okay, so the cotangent is x over y, which would be -2 over 3. And that's what we wrote on the line. Yay, we did it. Okay, now B is the same thing. This is just in a different quadrant, so we can practice drawing what that triangle looks like. So when you're drawing the triangle, you do want to think about where is that going to end up. This is +5, -2. So over 5, down 2, and then origin to point, and then point to x-axis so that it makes a right triangle. Okay, so then my x was 5, this was -2. I'm going to find r. Remember, r is just the square root of x squared plus y squared, like we wrote on the first side. So x squared, 5 squared, plus -2 squared is 25, plus 4, which is the square root of 29. There are no perfect squares that go into 29. So we are going to leave it just like that. All right, and now we can find the trig functions. All right, so step 2, your trig functions. I like to start with sine. So my sine of theta, which is y over r. This is my x, this is my y, this is my r. So I have -2 over root 29, and then I have to rationalize. Okay, so you don't want to keep that on the bottom. If you want, though, that is simplified. So the reciprocal, the cosecant, we know is going to be -root 29 over 2. But we do want to rationalize this as well. Okay, sorry, I'm trying to make it better for you to see. And I'm just going to write the final answer on the line here. So -2 root 29 over 29. And for cosecant, -root 29 over 2. Okay, if you're feeling confident at this point in finding them, please feel free to find them on your own, and then you can just scroll to the end of the video to check your work. I'm perfectly fine with that. So your cosine is x over r. So you have 5 over root 29. And then you know that the secant is going to be the flip. Okay, and then we just need to rationalize here. So 5 root 29 over 29. And again, those aren't going to simplify because they don't have any common factors. If both numbers are on the outside, you can reduce them if possible. But they either both have to be on the outside or both on the inside. Okay, and then the last one is the tangent. Oopsies. Okay, and your tangent. And some of you might be thinking, oh, isn't this the exact same thing as SOHCAHTOA? Well, yeah, it is. It is the exact same thing as SOHCAHTOA. The reason why we are relating this to X and Y is we are going to be using the trig functions with coordinates, with your X and Y coordinates and with the radius, which is why we want to start thinking of this in different terms. All right, so we got -2/5, and then the cotangent is -5/2. It's the reciprocal. Okay, so here are all of your lovely final answers, and you are ready to do your homework. And then if you do have questions, go ahead and message me on the assignment. And remember, I do have my office hours on Thursday. And yeah, I will talk to you guys soon. Don't forget to fill out your Google form as well. Have a good one. Bye.